There are sequences where the difference is not seen at first glance, but at the second. They are referred as quadratic sequences. Learn about them here in Mathematics of Engineering. Quadratic sequences work with differences and not ratios, but from the second level. The common difference is discrete and the formula follows a quadratic form. With the sequence 5, 8, 13, 20, and 29, we can take the difference of the terms and we get varying values, such as 3 from 8 minus 5, 5 for 13 less 8, 7 from 20 minus 13, and 9 from 29 less 20. These values are the first differences. If we attempt to subtract these once again, like 5 minus 3 is 2, 7 less 5 is 2, and 9 decreased by 7 is also 2, we can find the second difference, which is already constant. Being a quadratic sequence, its formula would be derived from the quadratic formula. The nth term u sub n is a times n squared plus b times n plus c. The conventional way of looking for the general formula is to iterate the sequence in different terms, and then the rest of the formula is generated similar with arithmetic sequences general formula procedure. We can show the procedure in detail with an example having first terms of 3, 7, 13, 21, 31, and 43. First, we check if the pattern is truly quadratic in nature, so take the first differences, starting with 7 less 3 as 4. Then 13 minus 7 gives 6. Next is 21 less 13 is 8. And also, 31 minus 21 is 10. Then we have 43 minus 31 gives 12. These are varying values, but they are still taken as first differences. Now we continue the procedure by 6 minus 4, which is 2. Also 8 minus 6 is 2. 10 minus 8 is 2, and 12 less 10 is also 2. Having a constant value for the second difference is a proof that the sequence belongs to quadratic type of progression. Now for the formula, we start with the first term, which is taken from the first term of the second difference, and divide this by 2. Then attach n squared to the answer. In the example, we have 2 divided by 2, which is 1, and attach n squared, making the first term of the formula as simply n squared. Next is to iterate the partial formula and compare the values with the original sequence. We start with n equal to 1, so n squared is 1 squared, which is 1. Then, at n equal to 2, the first term is 2 squared, which is 4. At n equal to 3, the first term is 9. At n equal to 4, we get 16. Moving to 5 for n, yielding 25, and with n equal to 6, the first term is 36. Subtract all these values from the original sequence, so 3 minus 1 is 2. Then 7 minus 4 is 3. Also, 13 less 9 is 4, and 21 less 16 is 5. Then 31 less 25 gives 6. And lastly, 43 minus 36 is 7. From this level, take the difference of the numbers. 3 minus 2 is 1, 4 minus 3 is 1, also 5 minus 4 is 1, and 6 less 5 is 1. Then 7 minus 6 is 1. Now that this set is constant, we can equate 1 with n. We already completed two terms of our equation, and that is n squared plus n. Then again, we iterate the values using this partial equation, so at n equal to 1, the expression gives 2. With n equal to 2, 2 squared plus 2 is 6. With n equal to 3, 3 squared plus 3 is 12. Then with n at 4, we get 20. Also, with n as 5, the expression is 30. And at n equal to 6, 6 squared plus 6 is equal to 42. Now we can subtract and check the difference where we get 1 constantly from 3 minus 2, 7 less 6, 13 minus 12, 21 decreased by 20, 31 minus 30, and 43 less 42. And since the difference is already equal, we can take this value as the constant term in the quadratic equation. Finally, the equation for this sequence is u sub n is equal to n squared plus n plus 1. Example 2 has the terms 1, 0, negative 3, negative 8, negative 15, and negative 24. Again, we work with the first difference, starting with 0 minus 1 is negative 1. Negative 3 minus 0 is negative 3. Negative 8 decreased by negative 3 is negative 5. Negative 15 minus negative 8 is negative 7. And negative 24 minus negative 15 is negative 9. Note that they are varying numbers, so work with the second difference. That is negative 3 minus negative 1 is negative 2. Also negative 5 less negative 3 is negative 2. Then negative 7 minus negative 5 is also negative 2. And negative 9 minus negative 7 is negative 2. Having all negative 2 for the second difference means that the sequence is quadratic. The first term of the formula for the sequence is from the second difference, negative 2 divided by 2 to have negative 1. This will be attached with n squared, so the first term of the formula is negative n squared. Now iterate the terms of starting with n equal to 1 to have negative 1. At n equal to 2, the first term is negative 4. With n as 3, the first term becomes negative 9. Moving on to n equal to 4, the first term is negative 16. And also, if n is 5, the first term results to negative 25. And finally, with n as 6, negative of 6 squared is negative 36. Subtract these terms from the original sequence to have the first difference. So 1 minus negative 1 is 2. 0 minus negative 4 is 4. Also, negative 3 minus 9 is 6. Then, negative 8 minus negative 16 is 8. Negative 15 minus negative 25 is 10. And lastly, negative 24 minus negative 36 is 12. Take the second difference of these values for the second term. That is 4 minus 2 is 2. 6 minus 4 is 2. 8 minus 6 is 2. 10 minus 8 is 2. And also 12 minus 10 is 2. Having them constant, we can now attach the variable n, making the second term of the formula 2n. At this point, we can combine the first two terms of the equation as negative n squared plus 2n. Again, iterate the expression from n equal to 1 to get 1. At n equal to 2, the expression turns as negative of 2 squared plus 2 times 2, and that is 0. With n equal to 3, the expression is negative 3. At n equal to 4, we get negative 8. And also at n equal to 5, the expression becomes negative 15. Lastly, if n is equal to 6, the expression is negative 24. So with these values already known, we subtract them from the original sequence to have the value for the constant, and that starts with 1 minus 1 is 0. Then 0 less 0 is also 0. Negative 3 less negative 3 is 0. Also negative 8 minus negative 8 makes 0 too. Negative 15, take away negative 15 is 0. And also negative 24 minus negative 24 is also 0. And since all values turn out the same, this is taken as the constant of the formula, where c is equal to 0. So the equation for the nth term of the sequence is u sub n is equal to n squared plus 2n.